Okay, we're back with part 2 of survival analysis in R. This is Ryan Womack, data librarian at Rutgers University, and I hope you've gone to the site and downloaded the R code from libguides.rutgers.edu/data_R, and I hope you have installed all the packages in section 1. If you haven't done that yet, you might want to pause and just come back. And we're going to just jump right into the analysis in R of our sample data set. So in fact, the survival package here is the one that has most of the standard functions for survival analysis. However, we are going to see the use of a few other extra packages that give us a little more oomph along the way that we will see. Okay, so going to section 2. We're going to work with just one sample data set for this set of exercises. That is, I'm calling it GBCS. It is an extract, a small extract of 100 observations from the German breast cancer study. And this is something that I had done as a past project. So the code itself is relatively complete in terms of it's analyzing a lot of different variables, a lot of different combinations to get a complete picture. We are not going to run every line of code in the videos because we can see what's happening without going through all those steps. So just so you're aware, the code may look a bit lengthy, but we're not going to talk through all of that. So let's bring in the data and look at what it is. We can see there's just a few variables. There's an ID variable. There's age. So okay, these are human subjects, women who've had breast cancer, and the question for the study was they've been treated for breast cancer, and so what influences the recurrence of breast cancer? And so we look at the age of the women, whether they've gone through menopause or not, whether they've had hormone therapy, and also two physical measurements, the number of progesterone receptors and the number of estrogen receptors that they have. Those are hormone, measuring their sensitivity to hormones in the body. And then there's really one primary response variable, which is rec time, is what it's called in the data set. That is the recurrence time until breast cancer recurred in the subject. And if the subject did not have breast cancer recur during the period of observation, which was a few years in this study, but it was not forever, then the observation is censored, as we discussed in part 1. That's the real difference in survival data, is that we have this flag whether the data has been censored or not, meaning we hit the end of the study and we didn't really observe what we were waiting to see. And so those two combined will make our survival data, rec time and sense rec. All right, let's just continue looking at the data a bit. We can look at just a basic summary of those variables, whether the data was censored or not. Now a 0 indicates that the data is censored and a 1 is not censored. So in this case, 58% of the data, we actually have people who have an observed recurrence of cancer. And so our rec time is one variable. This is one thing in censored data, is that you just can't take a straight median and think that that's an accurate representation of the average or the median amount of time that it takes to recur, because some people didn't recur and we don't know how long it would have taken them to have a recurrence, if ever, because we didn't observe them forever. So we'll see how to deal with that in just a minute. Okay, so we want to kind of explore this data a bit, and so the code walks through some visual exploration of the data. We can see the distribution of age of the subjects here are skewed to somewhat older patients, but not extremely old, reflecting the incidence of breast cancer. If we look at other things like the number of people who've gone through menopause is actually 63% of our 100 subjects because they're somewhat older. Did they receive hormone therapy or not? We can just sort of walk through those things. And I'm going to dwell more in this session on the R methods rather than the meaning of all this from a medical perspective. But just, so you have that context. One key thing to note is if you look at the both the estrogen and the progesterone receptors have this kind of very skewed distribution. A lot of subjects have very low number of receptors, and then there's a smaller percentage, but not insignificant number, who actually have this whole distribution of higher numbers of hormone receptors. Now that data, because it's not normally distributed, is something that we are going to want to transform. And if we do a log transform on any sort of data that has that skewed distribution, that's often a thing that will help a lot. So in this graph, the left-hand side is the raw data, and the right-hand side is the log transform of the number of progesterone receptors. So if we take the logarithm, we have a much smoother distribution of data, smoother in the sense that it's more evenly distributed, which from a statistical point of view is more tractable. So we're going to want to do log transforms of this type of data. Same is true for estrogen. I'm not going to run those plots right now. We could also walk through some of the plots. This is the little section marked plots at line 49 in the code. You can test some of these yourself. I won't run all of them, but it's hard in most cases to determine a pattern in is there a direct association, a really clear association between some of these variables and the time to recurrence. So we're going to need to do more sophisticated analysis to figure this out, right? That's what our survival analysis is going to do for us. So one in particular, though, has a bit of a difference. If we look at the censored flag, right? So remember, a 0 is censored data and a 1 is uncensored data. Here there's a clear pattern, right? We've got a lot more high numbers among the uncensored data and low numbers among these high numbers among the censored data and low numbers among the uncensored data. So if there's a recurrence, it happens at all different sort of dates, but it often happens soon. A lot of the subjects, though, in the censored data, they were in early in the study, and they went through the whole study without having a recurrence. So, and then the study ended. So the maximum number in the data set is like 2,600 days. So obviously, if you're going to sort of age out of the study like that, you tend to have a higher number. So here's one difference. And we can look at things like correlation between just a correlation matrix of all the variables against each other to see if there's any things that jump out. Now obviously, like age and menopause are strongly correlated because you have to get to a certain age for that to happen. A lot of the other things are not too terribly strongly related. Even the estrogen and progesterone receptors. Some people are high in one and not high in another. That's only a 0.42 correlation. So again, the presence of relatively low numbers here means that we're looking for something else that's going to help us explain this data. And let me stop here. That's just a kind of introduction to the data set. And the next part, keep these in relatively short segments, the next part will talk about the survival object itself, which is a very important topic, so I want to highlight that.